And welcome, guys. Today I'm going to be talking about balancing equations. Now, this is one of the most important skills you'll need to use in chemistry. You'll use it all throughout, and it's one of those things where the more you practice, the better you'll get. So it's fairly simple. Start off with our first equation. Hydrogen gas mixed with oxygen gas gives us water. Now, the point of balancing is to put the same amount of elements on both sides. So we have 2 hydrogen on the left, 2 hydrogen on the right, 2 oxygen on the left, and 1 on the right. So as you can see, it's unbalanced. The first thing I like to do is I like to make sure I draw a table to keep myself organized. It's simple, it's easy. So here's a table, something like this, where hydrogen, you have our elements, our left side of the equation right here shows going to the next side, our right side here. So the first thing I'm going to do is I'm going to even out the oxygen. So I'm going to multiply our water by 2. But what this will do will multiply our hydrogen as well. So it's 2 times 2. So it gives us 4 hydrogen. Add that to the table. We have 2 hydrogen on the left, 4 hydrogen on the right. Everything else is balanced, so what we need to do is we need to go back to the left side of the equation and multiply hydrogen gas by 2. Doing this will even out our equation and give us 4 hydrogen on the left, 4 hydrogen on the right, 2 oxygen on the left, and 2 oxygen on the right. So that is a balanced equation, and this is the final balanced equation. Now, another problem we have is sodium plus water gives us sodium hydroxide and hydrogen gas. First thing we want to do is we want to draw a table. So we have sodium, 1 on left, 1 on right, hydrogen, 2 on left and 3 on right, and oxygen, 1 on left and 1 on right. The first thing we want to do is start with the highest number of unbalanced elements. So we look at hydrogen. We have 3 on the right and 2 on the left. So what we do is, since we can't multiply 2 by anything to get 3, we multiply both sides. But let's just start out with sodium hydroxide first. We want to find the least common denominator, which in that case is 4. So we multiply sodium hydroxide by 2. Add it to our table. As you can see, it boosts up to 4, but it also boosts up our sodium and our oxygen. So what we do now is we multiply the hydrogen on the left side, which is in our water. So we multiply our water by 2 and add it to our table. That balances our hydrogen, and it also balances our oxygen. Now we only have one thing left unbalanced, which is our sodium. So we want to go back to the left side and multiply by 2 and add it to our table. And you can see that everything is balanced. And that is our final balanced equation. Now this problem is a little harder. I'm going to go by it a little quicker. So we have aluminum plus hydrochloric acid gives us aluminum trichloride and hydrogen gas. Now we draw out our elements in our table. So we have 1 on the left, 1 on the right, 1 on the left, 2 on the right, 1 on the left, 3 on the right. So we start with our highest number of elements, which in this case would be chlorine. So we go over our left side and we multiply hydrochloric acid by 3. So that gives us 3 chlorine and 3 chlorine balanced, but it also multiplies our hydrogen. So we have 3 hydrogen and 2 hydrogen. We need to find the least common denominator, which is 6. So we go back and multiply our hydrochloric acid and our hydrogen gas on both sides. So that gives us 6 hydrogen. 6 hydrogen evens it out, but it also multiplies our chlorine again. So we have 6 chlorine instead of 3, and so it's unbalanced. So we have to go back to the right side and multiply our compound with chlorine by 2. But what that does is it also messes with our aluminum. So we have to go back to the left side again and multiply our aluminum by 2. Add it to our table, and everything is balanced. This is our final balanced equation. This is the equation we can work with, and this is the one that we want. And thank you guys for watching. This was Balancing Equations.